Hey folks, back again for the last bit of 4.6. So we're going to be looking at complex fractions, which is kind of just a spin-off of the order of operations. The biggest thing is when you see a complex fraction, it just looks nasty. So it looks complex. But really they're just fractions that contain fractions. So how we take care of them is that we treat them like division. So if we think of this, middle fraction bar as a division symbol, we can rewrite the problem as 4/7 divided by 12 over 21. And now it's easy, right? So we can use our same switch flip on this. And then we can cross cancel. So the 4 cancels with the 12. The 7 cancels with the 21. So we end up getting 3 over 3, which is just 1. So that's kind of a nice one. But it just illustrates the process for you. So let's do it a few more times. Make sure you get it down, and then you're all set. So let's try this one. So 2/3 over 8/9. So right off the bat, we can rewrite this as 2/3 divided by 8/9. And then we can switch it around. So we got 2/3 times 9/8. And now we can do a little cross canceling. So the 3 and the 9, the 2 and the 8. So it looks like we got 3 over 4. Now, for something like this one, it looks a little weird because you got a fraction on top and you got an 8 on the bottom. But how can we make it look like a fraction? Yeah, we can just put it over 1. So if we put it over 1, now we got the same thing. So it's pretty fast. So 4/7. Now, if you are feeling confident with this stuff and you want to skip some steps, you can do that. So we know that we're going to have to flip this around, but we have to change it to multiplication. So make sure you do both at the same time. Change it to multiplication and flip it at the same time. Don't do one without the other. Otherwise, it's going to mess you up. So cross cancel. And it looks like we get 1 over 14. So, okay, so numbers, not so bad. Well, let's throw some letters in there and see what that looks like. So we have x to the second power over 3 all over x over 6. So we got that. Now let's just kind of cut to the chase. So we're going to flip it and multiply it. So we got 6 over x. Now how do we cancel this stuff down? I mean, we can do the 3 and the 6 pretty quick. But as far as the x to the second power and the x, remember what we said. If you think of it in expanded form, you can cancel one of them out. So cross that out and say, okay, well, I'm going to cancel this x and that x. So we got a 2 left on top here. We got an x left on top here, and that's it. So we got 2x over, and this is going to cancel out completely on the bottom. So we just got some 1s. So we had 2x over 1. Now remember what we said before. If it's anything over 1, you don't need it. You don't need the 1. So we can just drop it off and just write it as 2x. So not terrible, but just be careful with those exponents. Make sure you expand it out and just cancel the appropriate number of repetitions that you see. So now these last two have a little bit more substance to them, but the big thing to keep in mind is that you got stuff to do on top and you got stuff to do on the bottom first. Do that first before you do the division. So if we're going to add and subtract these, we're going to need an LCD. So it turns out, though, that the LCD for the top is 4 and the LCD for the bottom is 4. So that's nice. So we end up getting something over 4 plus 1 over 4 something over 4 minus 1 over 4. Well, what's the something over 4? Well, got to multiply by 2, right? So it should be a 2 in both cases. So in this problem, we end up getting 3/4 over 1/4. All right, and now it's just the same as it was before. Rewrite it as division, and then rewrite it as multiplication. So we're just going to skip to the multiplication step. So we had to flip that 1 over 4 to 4 over 1. And now we can cross cancel. So it looks like we end up with 3 over 1, which is 3. All right. So the last one, same as the previous, we need some LCDs. Now in this case, the LCD for the bottom, well, 7 goes into 21 evenly, so we can just use 21. On the bottom, though, 9 goes into 18, so 18 is the LCD. So you're probably saying, well, wait a minute, don't they have to be the same? Doesn't it all have to be the same? No, it doesn't. That's the beauty of it. You can have a different LCD on the top and the bottom when you have a problem like this. Because we're going to be dividing later on, we'll kind of worry about those denominators being different later. So let's rewrite them now. Okay, so we got our 21s on the top, we got our 18s on the bottom. So now what goes above the 21 here? So we had to take the 7, we had to multiply it by 3 to get to 21. So if we multiply the top by 3, that's going to give us a 9. And then on the bottom, so we had to multiply it by 2, right, to get to 18. So the 2 gets multiplied by 2, so that's going to give us a 4. All right, now we can combine the tops on both of them. So we have 4 over 21 and 3 over 18. Now, an optional step in here is to reduce fractions down when we can. So the top fraction, 4 over 21, we can't do anything with that, but 3 over 18, we could reduce that down to make the numbers a little smaller. So I would recommend that. So 3 goes into both of those, so we can reduce it to 1/6. And now we can do our multiplication. So we got 4 over 21 and times 6 over 1. So now we can do a little bit of cross canceling because 3 goes into both of those. So we'll change that to a 2, change that to a 7. So what's that going to give you? So multiply straight across. So we do get 8 over 7. Now, since we know about mixed numbers, we should change it into a mixed number. So what's 8 over 7 as a mixed number? Should be getting 1 and 1/7. So that would be it. Alrighty, so that wraps up 4.6 and it wraps up the chapter. So we're going to be having a test soon, so make sure you prepare for it. The review will be coming up shortly. So see you in the next videos.